Hello, I'm Mr. McBrien. This is TEJ20, Turing 10, working with the mouse. Yesterday we talked about functions and procedures. Today we'll talk about something a lot more fun, working with a more intuitive device for interacting with our applications. So if we want to talk about graphical user interface, most of you won't even really remember the DOS prompt. We've used it a few times in TEJ20, but really it has only very limited utility today. Old Bill Gates gave us some more advanced tools to allow us to work with graphical interactions, and of course he copied those from others. Now, we can use these tools. Turing has tools for this, and we can make a much more user-friendly piece of software than using the keyboard. Some of the advantages of the mouse: we don't have spelling or capitalization mistakes. We can click on menus for prompts, or even roll over menus for prompts. And, of course, we're used to mice. So, as an illustration of a very simple way that a mouse could have helped us, the application I wrote here asked for a number between 1 and 10. And the user did something unanticipated. The user typed the word rather than using the number pad. And our application's just confused by that. We didn't anticipate that kind of interaction. In contrast, if the user had clicked on a 10, we wouldn't have had a problem. It's worth noting that mice, their days are likely limited. They're an endangered species. But for now, they're a really good option for us for an interface. Okay, before we go any further, here's a reference for some of the material here. You can copy this reference into your browser if you want, or you can do a simple Google search on how to use a mouse in Turing and you'll retrieve what you need likely. Alright, part 1, locating the mouse. What we do when we want to allow the user to use a mouse, we create a loop, and the loop constantly monitors the mouse to figure out what's going on. So at any given time we can know where the mouse clicker is, where the pointer is, and at any given time we can know whether it's been clicked. And one aspect of this is the mouse.where command. Mouse.where outputs an X and Y location, and B is a Boolean indicator of whether or not the mouse has been clicked. Now, a quick warning about screen size. You may have decided to use the code that you found in the reference as a starting point. One of the challenges in using the mouse in Turing is that it can throw errors when it tries to use a mouse location that's outside of the active window. It can only place text or graphics inside its own window, and if it tries to use a mouse location outside of that window, it'll throw an error and crash. Now, when you design applications that use a mouse, for starters, be sure and you make the window large. If you do that, your application will be more robust inherently. So one way to do that is just set the graphics to maximum. The example code that's available online through the reference, it reports the mouse locations constantly, and it'll crash instantly as soon as the mouse moves outside of the window, even very briefly. And that's no big deal. You can imagine various ways that you can design around this. For starters, don't have it report the mouse location where the mouse is. Or you could have it stop reporting as soon as the mouse moves outside of the window. And then you have, once again, a robust application. Go ahead and play with that if you want to. And we can go on from there. All right, part 2, detecting a click. Most applications, we don't care about the location of the mouse until the user says that it's important, until the user clicks. And in our loops, we can just ignore the location of that until the button result comes out as a 1. And when that happens, we can retrieve the location of the mouse and use it however we want to. So activity 1, let's write an application that detects the location of a click. Write a loop that detects that the user clicks a button and retrieves the mouse location when it does. And you can output the location of the click itself to the screen. And so your output should look something like this. I clicked at X44, Y690, and this is the output that I got from my Mouse Reader 2 program. So go ahead and implement this and then come back to the slides. All right. It can be very interesting to know whether there's an intersection with a given object. We can let a user click a spot on the screen and draw. But a more common requirement is to first draw an object on the screen and then figure out whether the user's clicked on that object. And this is easiest with rectangles. So what we can do is, for activity 2, draw a bunch of rectangles on the screen. Remember, we've done something very close to this before. So write an application that draws a grid of gray rectangles on the screen. And if the user clicks on one of these rectangles, have that rectangle turn blue. And if you're looking for a challenging extension, this is a fun one. Instead of detecting rectangles, detect clicks on circles. I think you'll find that a lot more interesting. Okay, so in summary, mice may be becoming dated, but they still are an important interface device, as we well know. Turing has tools for this, and your applications can use a mouse really fairly easily with a bit of work. For your homework, please complete activity 1, detecting mouse locations and writing the location of the screen. Activity 2, changing the colors of the rectangle in an array when the users click that rectangle. And I'd invite you to think about what kind of applications you can see for the code involved in activity 2. Really, there are a fairly large number of them. But think about some of those and have those ready for class. Thank you, and have a great day.